Yes, I'm audible.
Yes, sir.
Last we have discussed hyperfine splitting. Yes, no?
Yes, sir.
Yes, what the value of hyperfine splitting of hydrogen atom? Explain.
Yes, sir. Sir, in the case of hydrogen atom have one spin, that is S is equal to 1 by 2. S is equal to 1 by 2, and it has value of M spin. Value of M spin is equal to plus minus 1 by 2. Uh, Plus minus 1 by 2. So when the external magnetic field B is equal to 0, then in the curve of this in the curve of external magnetic field energy versus B is the external magnetic field, and they when the B is equal to 0, they both are degenerate. That is, alpha and beta both are degenerate. Alpha is up spin state, beta is down spin state, with M plus minus 1 by 2.
Yes. Next is methyl molecule, methyl radical. Methyl radical. Yes, one question is left. Hydrogen atom, how many transition will be there? And what the selection rule of hydrogen atom in hyperfine splitting? Yes, I'm audible.
With three proton has I is equal to 1, and therefore three proton have 3 by 2. Therefore we get, at first it is separated into plus half and minus half. Then when it interact with the 3 proton, then we get 4 value, that is plus 3 by 2, plus 1 by 2, minus 1 by 2, and minus 3 by 2. And when this minus half value interact with the 3 proton, then we get the value of minus 3 by 2, minus 1 by 2, and plus 1 by 2, and plus 3 by 2. And from this value, we get 4 spectra, that is 3 by 2 to 3 by 2, and minus half to minus half, and then plus half to plus half, and minus 3 by 2 minus 3 by 2, because delta ms is equal to 0. So from this we get. Hello, sir.
Yes, yes, carry on.
Yes, sir. From the methyl radical we get 4 lines.
Yes. Next one for benzoquinone radical anion. According to hyperfine splitting, what will be the transition? What will be the selection rule? What the according to
Sir,
intensity
according to
ratio?
one. Yes, sir. Selection rule is same, that is delta ms is equal to 0, and from this value we get that delta ml, in this case benzophenols ml is 1, so it is separated into plus 1, 0 and minus 1. And from this curve for the benzophenone we get three line.
Benzioquinone in 3 lines. Transition, how many transition? Yes, sir. Spectrum will show is quintet. 5 line will be there. What the
Yes, sir. Yes, sir.
yes? What the
Pipeline.
intensity? What the intensity ratio of 1,4-benzioquinone?
Intensity ratio.
Yes.
Yes, intensity ratio for N is equal to 5 is 1 minute. 1, 3, 3, 1, 1, 4, 6, 4, 1. Sir, intensity ratio will be 1:4:6:4:1.
Yes. 1:4:6:4:1. Yes. Quintet will be there. Yes, na. 5 line.
Yes, sir.
Yes. And spectrum. What type of spectrum in 1,4-benzioquinone? Radical anion? Expectation.
Yes, sir.
Spectrum.
Spectrum will be quintet. That means 1, 2, 3, 4, 5. Sir, it will be quintet, and the distance between the two spectrum will be the a hyperfine splitting constant. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it is the spectrum.
Yes. 5 spectrum. Yes, right. But your spectrum, you saw the spectrum is equal position, but there is difference now. 1:6 ratio, 1:4
Yes,
ratio, 6:4:1.
yes,
One
sir. 1,
6 to
4.
6 one spectrum is
Yes.
large and then reduced to 4. 4 is equal, 1 is equal.
Yes, sir. 1, 4, 1:4, 6, 4, 1.
Yes. Right. Next one is methyl radical. What the spectrum of methyl radical we have discussed, and how many lines?
Yes, sir. Sir, methyl radical has 4 line, and it is methyl 4 line, and it is quadrat, and it has intensity ratio is 1:3:3:1, and it has a spectrum is 1:3:3:1. So 1:3:3:1.
Yes. 1:3 ratio, 3 ratio E. Number of signal, how many signal present in methyl radical?
Sir, four signal is present.
Yes. And experimental spectrum of methyl radical?
Sir, it is the experimental spectrum, and we get the peak from the derivative value. That will be I think it is the experimental spectrum.
Yes. Next, hydrogen radical. What the intensity ratio of hydrogen radical and experimental spectrum of hydrogen radical? Explain once again.
Yes, sir. Hydrogen radical from the curve we see that hydrogen radical have two signal, because in this case also delta ms is 0. So the signal will be from plus 1 by 2 plus 1 by 2 and minus 1 by 2 minus 1 by 2, and it is doublet 1:1, and the signal will be and the experimental signal will be 1:1 doublet 1:1.
Yes, 1:1. Doublet.
Yes, sir. 1:1. Sir, this is the signal, experimental signal of hydrogen radical.
Yes. The next is naphthalene radical anion. What the number of lines of naphthalene radical anion? ESR line.
Free radical
Anion.
free radical anion. Sir, free radical anion, I think it will be the 25 line.
Yes. How to calculate?
Sir, I remember that the calculation is from the formula of 2Ni+1, but I don't exactly remember like how to calculate. From the formula of 2Ni+1 or N+1.
2Ni+1, 2Mi+1. Yes.
Yes.
Anthracene radical anion. What will be the ESR line?
So anthracene radical anion will be 75 line. We also from calculation of the alpha beta, if we consider alpha and beta, that is the carbon and proton, and from the formula of 2Ni+1 and 2M+1, then we can determine.
Yes. Value is anthracene is 75 line.
So anthracene will be 75 line.
Yes.
Naphthalene is 25 line.
Yes. Triphenyl methyl radical.
Diphenyl methyl radical. Sir, diphenyl methyl radical will be 196 line.
Yes. Next one is benzene radical. Anion is number of ESR line.
Anionic benzene. Sir, I don't remember what is the anionic benzene line.
Number of lines is 7. 2Ni+1. 2 multiply 1 radical, C6H6 radical anion. Radical anion na.
Okay, okay.
2 multiply 1 multiply 3 plus 1 to 7.
2 Ni plus 1. So C6H6 minus. So 2 into Ni plus 1. So in this case, 2 into 6 Ne6. Ne6 and I is equal to 1 by 2. 1 by 2 plus 1. And also therefore that 7 line.
Yes, 7 line. Next, NH2 radical. NH2 radical. What the number of line?
NH2 radical. NH radical 2 into N1 and 3 by 2 plus 1 and 2 into 2 into 1 by 2 plus 1. So it is 3 plus 1, 4. So 12 line.
12
So
line.
NH2 will be 12 line.
NH2 radical line is 9.
So 9.
Yes. NH2
So
radical.
how 2 Ni plus 1 from the
2
calculation of
Ni
2
plus
Ni plus
1.
1.
Yes. The number of lines is 2 Ni plus 1, 2 Mi plus 1. Yes, no. So 2 multiply
Yes.
1 NH2 I for 14 N is equal to 1. I बराबर 1. So 2 Ni to
1, yes, sir.
multiply 1 plus 1. So 3 and 2 multiply 1 plus 1 so 3 multiply 3 9.
Yes, sir. The value of Mi is what for N?
Yes, 2 multiply NH2. Yes. First is 2 Ni plus 1. 2 multiply 1 plus 1. Yes, so 3. Multiply 2 Mi plus 1. So 2 multiply 2 hydrogen. Multiply half plus 1. So 2 cancel. So 2 plus 1 3. So 3 multiply 3 9. Yes.
Yes, sir. Yes, sir. I get it. Yes, sir. I get it.
Yes. Next one NH
9.
and D2 radical and D2 radical.
And D2. And D2 will be 2 into nitrogen is 1 into 1 plus 1 and 2 into 2 D2 into 1 plus 1. So 2 plus 1 is equal to 3 into 2, 4 plus 5, 3, 5, 15. 2 into 1 plus 1 is equal to 3 and 2 into 1 plus 1 is 5. So 15.
Yes, 15, right. Answer is correct. Yes, right. Yes, ESR is overall is completed. Next, last one question is what the main daily life example of ESR?
Daily life example.
Daily life example is food safety and quality, detections of irradiated food, study of food oxidation, monitoring of shelf life, material science, study of magnetic materials, analyze of semiconductor detect, understanding catalysis reactions, developing new materials, medicinal diagnostic, environment monitoring, so many daily life examples.
Sir, if I tell that in free radical or polymerization reaction, we can also see.
Yes, sure. Yes. Next one is drawback limitation.
Sir, drawback limitation is that sometimes the radical are getting quenched or through antiferromagnetic coupling also the radical are getting into coupled. So from that case from the reaction we cannot determine the if radical is present or not. So we cannot determine the concentration. We cannot know the concentration of that radical from the ESR spectra.
Yes.
Yes, sir.
Yes, most overall is completed, your NMR and ESR. Yes, next day we will discuss in the left part of your NMR, like car classification, Pascal triangle. Yes, no, you have to study, you look them.
Yes, sir. From three book I have to study. Sir, then sir, I have to start chemical kinetics. Sir, chemical kinetics, I have studied Laidlaw and Purishama Patania.
Yes,
Also,
PSP and
sir,
KL Kapoor. PSP and KL Kapoor, good book. PSP and KL Kapoor.
yes, sir. But sir, in my semester, I have to follow Laidlaw. That's why.
Yes, no problem. Yes, you look them any book. But first is according to my side is PSP and KL Kapoor.
KL Kapoor, okay. And sir, I have to one question. That sir, many students are like I see in your status that IIT Guwahati many students are in GATE 50 rank. Sir, they are also preparing for BARC OCS mock interview.
Yes, someone is enrolled, but they are waiting in result.
Okay, sir. Okay.
Because result is out is 20, but they have appeared in 9. So waiting for result in GATE result and also for written exam, both.
Okay, sir.
Yes, no. Next new topic is your chemical kinetics. So chemical kinetics is 1 day gap. Tomorrow and after tomorrow we will discuss your next second topic. Yes, no.
Yes, sir. I think sir tomorrow is my left part of NMR.
Tomorrow, okay, no.
Tomorrow morning.
Yes, tomorrow. Tomorrow.
Yes, sir.
We
Sir,
will
yes, sir. Actually, if you take mock interview like daily basis, then I have get some study for motivation.
Yes, your motivation, but something 2-3 day I am busy in outside. Nowadays I am out of station. After 27 March we will discuss continue. Yes, now.
Yes, sir. Okay, sir.
Because
Thank you.
nowadays I am out of station. Yes, now. But we have already discussed. Okay. So next day we will discuss in NMR. Yes.
Yes, sir. In my left part, I have also covered from Pavia that I not read always also.
Yes, sure. And derivation also.
Okay, sir.
And selection rules. You have to study about selection rules.
Yes, sir. Selection rule for NMR spectra also, right?
NMR, ESR, rotational, vibrational, electronic, all 5 part.
Yes, sir. Also I covered. Okay. Thank you, sir.
Okay, thank you.